Hello everyone, this is Jay from BTYT Tech Library. Today we are going to solve LeetCode problem number 1, to sum. I think this one is the first problem many people starting on LeetCode. It's labeled an easy problem, but I don't think it's a piece of cake. The question is simple. Given an array of integers nums and an integer target, return indices of the two numbers such that they add up to target. For this problem, we are going to solve it in two different styles. One is functional style and the other is imperative style. Functional programming style is more declarative, focusing on what to do, and more modular. So most cases, just rephrase what you want correctly, it becomes the code. The question, in other words, given an array of integers nums, we can filter out to get two numbers. That sum of them makes the target number and returns these two numbers index. Also, there is extra info. Each input would have exactly one solution, and we may not use the same element twice. Say one more time. Given an array of integers nums, we can filter out to get two numbers. On each element inside the list, except itself. Is there a number that you can add to one other element to make the target number? And then, let these two numbers return their index. If you're curious about the reason we use index of and the last index of functions, check the example 3. We can see actually this is one chain of functions. Let's run the code. On filter iterations, it finds a number in unsorted list to produce the target number by addition on each element. Time complexity, big O of n square. Now, how about the other style? Imperative programming is more hands-on control, focusing on how to do, and its explicit customized tuning makes code more performative, but sometimes error-prone. Actually, there is a way to scan the array only once if we specifically implement how to do it with two pointers. When you encounter a problem consisting of integers, it implies it contains hidden conditions. For example, numbers can be positive or negative, and they have the concept of being greater than others or lesser than others, which means that they can be sorted, have directions, and in many cases, sorting helps a lot. So let's think this way. Once we sorting the integer array, we can perform more effective searching. On the sorted array, let's place two pointers on edges of the array. Then check if sum of two pointers, two numbers, produce the target number. Since a sorted array has direction, if the sum of the two pointers' numbers is greater than the target number, move the greater size pointer to the lesser side. Otherwise, if the sum of the two pointers' numbers is less than the target number, move the lesser size pointer to the greater side. We will perform this process until the sum of two pointers matches the target number. Let's code it up. First, we need to sort the array. Place two pointers on array's edges. While the sum of the two pointers' numbers doesn't meet the target number, if the sum is less than the target number, we will move the lesser size pointer one step closer to the greater side. Else, move the greater size pointer to the other side. If we get a hit, we return the corresponding indices as an integer array. Let's run the code. Even though we scan only one time on an array, however, for that, we need to sort the array, which takes time complexity big O of nlogn. Finally, our performant friend, HashMap. Maybe we can achieve both efficiency and readability in a Kotlin idiomatic way. The ninth complement of a decimal digit is the number that must be added to it to produce 9. The ninth complement of 2 is 7. The ninth complement of 7 is 2. Let's cut to the chase. We are going to use inverse key value tricks on HashMap while taking advantage of the method of complement. Sounds complicated, but actually is not. Since input data type is array, we can set a hash map and loop through each array element looking for the target number's complement of current number. If the complementary number exists, we can just return the indices. If not, we are going to register the current value as the hash map's key and the current value's index as the key's value. So recap. With key value integer mutable map, loop through given an array's each element. In case of our map has the current number's complementary number, let's just return its indices as integer array. The other case, we're gonna register the current number as map's key and its index as key's value and keep it running. Let's run the code. In this way, we could not only skip the unnecessary sorting, but also harness the hash map's constant time performance, time complexity, big O of n. So today, we expressed our thoughts through two different programming styles. I know it's easy to fall into the temptation to just jump into the best one solution and move on to the next question. But in my humble opinion, it's worth taking time to try solving it in various ways with different styles. The competitive programming problem is literally the test for your problem-solving skills. But it can also be a good tool for training your skills. If I may use Zen metaphor, the problem, even the solution itself, is like the finger pointing the moon. We need to seek the moon, not the fingertip.